Unit Operation Classroom. Today we are discussing what is Grashof number and its importance in natural convection. My name is Shikhar Bhattacharjee. It says which one of the following ratios does Grashof number represent? We know Grashof numbers is given as a ratio of the buoyancy force divided by the viscous force. If we write it down in terms of the symbols, it is L cube. L is, of course, the characteristic length, surface of the plate height. G, of course, is gravitational acceleration. Beta is the volumetric coefficient of expansion. Rho is the density, and mu is the viscosity. I will explain where this Grashof number becomes important, and this is mu, of course. There's a viscosity, and mu, of course, is the kinematic viscosity. If you take these two, and that's equal to mu over rho, of course, that's mu. So this it can be written as like this one also. This is Grashof number is a very important parameter for natural convection. Let's say if you have a liquid and let's say it is being heated by let's say steam coil. So what happens? The liquid in contact with this coil gets heated up and its density decreases, so it rises up, and the cooler liquid comes down. So a circulation loop is established, and that is of course a key point in natural convection. The buoyancy force, therefore, this buoyancy force is a driving force due to density difference caused by the temperature difference, right? So this one that sets up the circulation loop. But the opposing force is the viscous force. That means its resistance to move. This resistance offered by the fluid. Okay, so this of course is a ratio, and we will see how to interpret this one. Um, Let us say if the Grashof number is low, then of course, as you can see, the buoyancy force is low compared to the viscous force, so that the liquid does not want to move. So this is a low buoyancy, and of course, this is going to be stagnant fluid because the liquid does not want to move, and therefore the heat transfer is mainly by conduction. So just by conduction, the circulation loop is not established. So in terms of the industrial practicality, for good mixing of the liquid or for heating a fluid using heating coil, we must use a starter if the Grashof number is low. So we have to, because the circulation loop is not established. Okay. Of course, if the Grashof number is between 10 to the power 4 and 10 to the power 8, that's moderate. It's called a laminar flow region, very weak natural convection. And if the Grashof number is high, 10 to the power 4, it's let's say around 10 to the power 9, then there's a strong buoyancy force that the good circulation loop is established and the turbulent natural convection. So under those situations, strong mixing by the natural convection, and of course does not need any kind of agitation or stir. Okay, so let's see which one of the options is correct. So buoyancy force, which one of the following is the Grashof number? So buoyancy force to inertia force, this is called the Richardson number. This becomes important when there's an external flow. That means both natural and the forced convection. When that is the case, we use this Richardson number. There's an inertial force, some kind of a forced convection. Okay. If there is no forced convection, no external flow, then it's just called natural convection. And under that condition, Grashof number is important. So this is, of course, the correct option. Okay. If there's a viscous force to capillary force, actually there's something called viscous force to surface tension force. Of course, in capillary force is caused by surface tension. That is called capillary number. So in terms of this option is also not true. And viscous force to inertia force, we know the ratio of inertia force to viscous force is Reynolds number. So this is the inverse of Reynolds number. So this also is not correct. This is not correct. This is not correct. This is the correct option. So correct option is B.